Welcome back, dear students. So I'm back. Your Adu is back with for your education, for your well-being, and for your studies. So now I'm so happy today. I started a YouTube channel. I posted videos. I started getting comments. I started getting likes, views, etc., etc. I'm so happy. Look, I'll forever continue this YouTube channel. It's my passion for giving lessons to others, or giving tips, tricks, etc., and providing knowledge to others. You know that providing knowledge will increase the knowledge of the person who's providing the same. So here I am nourished, as well as how am I nourished? I am nourished by teaching you. You are nourished by my lessons. So we both are having achievements only. At last we both are having achievements only. Without much ado, we will be going to our lesson. So today I am coming with a favorite but a very big lesson, in physics, class 12 physics, that is ray optics. This chapter, for sure, from this chapter one question will come for JEE mains examination. For sure one question is gonna come for JEE mains. For NEET also one question is gonna come. For CBSE also this lesson is important, because there are many derivations, etc., from this lesson. But now for today's class, we will be not dealing in the CBSE realm, but we will be doing it in a entrance coaching realm, because JEE mains are coming in 30 days. So we have to be prepared for JEE mains. So this session is a short session. Short means 1 hour, maximum 1 hour, and this session aims providing all the equations, all the concepts, etc., that we need for our JEE mains examination. So please like my video, the likes you are giving, and please comment on how's my presentation style. Did you understand something? If you have any doubts, if there is any mistakes that I did during the video, if there are any mistakes, you can correct me. If there are any doubts, you can ask. I will answer it to my best. So please share to your friends too, so that I can spread my knowledge to everyone. And this is a free tuition. Look, my class quality is one. I'm taking these stuffs and lessons from good books. As for chemistry and all, I am referring questions from Himanshu Pandey, etc., etc. I didn't start giving the questions from books, but I am referring good books. I am not referring one book at a time. I am referring lot of books. I am referring many lecture notes that I got, and I am looking NCERT textbook. I am mainly for chemistry. I did NCERT orientation, but physics we will be not doing totally on NCERT, because NCERT is only providing and the NCERT of physics is also not written in a good manner. So it's already 2 or 3 minutes I'm talking, and it's boring, I think. So it's time for us to start with ray optics. So ray optics is an important chapter, because for sure 4 marks. You can score 4 marks, sometimes 8 marks from this one chapter. Sometimes 8 marks, because this time the numericals were totally in 10, but now it's cut short to 5. So 2 questions from ray optics is difficult, but for sure 1 question from ray optics is sure. So ray optics is a chapter. It's a chapter that is really split into 2 parts. That is, one is reflection and refraction. And in reflection, in JEE main syllabus, they have only mentioned spherical mirrors in the syllabus. For refraction, they mentioned total internal reflection, prism, and lenses, and optical instruments, etc. So this chapter is lengthy, but this chapter it's a completely formula based chapter, and most of the questions can be directly dealt with. So it's a simple chapter. It's really a simple chapter. Without much ado, I'll be going to ray optics. But when we are telling in reflection, there is also one more thing that's out of syllabus, that is plane mirrors. But I think that without basic knowledge of plane mirror, if you are going to learn spherical mirrors and reflection, refraction, etc., you will be trapped, because in refraction questions there can be combination of concave or convex lens and silvering of one side as if like a plane mirror. So there are chances for questions where plane mirror concepts are mixed, even though it's not there in the syllabus. So we will be also dealing with basics of plane mirror. First one is a reflection. You know what is reflection? Yes, reflection is this is reflection. This is reflection. One second. Sorry, I was disrupted in between. Sorry. So reflection, you know that there is a laws for reflection. There are laws of reflection. And this is a very short class, like a one-shot class. So when you're listening, carefully listen that I'll be not explaining this laws of reflection. The first law is telling that incident ray, reflected ray, and normal should be in same plane. Should be in same plane. This is the first thing told. Next one is very important. Angle of incident is equal to angle of refraction. You know that this is the incident ray coming. It's hitting the plane mirror surface n dash. This is I, this is R. I'm just marking it. So the incident ray is coming like this. It is hitting on the plane mirror surface and it's reflecting back. So it's telling that the angle made by this incident ray with normal, this is called as angle of incidence. This angle will be equal to the angle of reflection. That is the angle made by reflected ray and the normal. So they both will be equal. I will be equal to R. This is the basics for reflection. Everything on reflection is basically what? Depending on this one formula. So that's about reflection. Now there is a vector form. For reflection. Vector form of reflection. What does vector form of reflection is telling? You know, in mathematics class 12 there is a chapter called vector algebra, and till 2022 I think, or 23, there was something called a box product. That means, or scalar triple product. So really this vector form of a plane mirror, vector form of reflection means what? It's just the box product of incident ray, reflected ray and normal. That is scalar triple product. That is I cross R cross N. This will be equal to 0. This is the vector form. What does this form means? That is I dot R cross N. Really box product of three vectors, box product means the scalar triple product, like this type, that is I dot R cross N. Box product of three vectors will be equal to 0 when I, R and N, or the three vectors are coplanar. You know that in laws of reflection it is told that incident ray, reflected ray and normal should be in same plane. So for sure they will be what? In the same plane. So they are coplanar. Hence they are coplanar, box product will be 0. So that is the vector form of reflection. Now we'll be talking on plane mirror. We'll be only talking very less on plane mirror because this class should be short, right? Because really this ray optics is a 40 or 50 hour topic, so it will take time. So no derivations will be there in the class, but just formulas needed for your excelling. So A, B, this is the normal, this is I, this is R. Now if we extend this incident ray, we get a ray like this. Really there was a deviation. Incident ray was deviated through some angle to make it the reflected ray. So this deviation, how much does this deviation measure? Really, you know, look, this angle I plus angle R plus this deviation should give us 180 degree, because this is a straight line and this total angle is how much? 180 degree. So with this We can solve it. You know that I is equal to R. So we can write 2I plus lambda equal to 180 degree. Therefore, the deviation or the angle of deviation is 2I minus 180 degree. 2I minus 180 degree. Okay. Now we'll be having a special feature of plane mirror. You know that plane mirror. This feature is familiar to everyone who have learned the plane mirror or the basic concept of optic in class 9 or 10, in 8th or 7th, I don't remember in which class you learned about lateral inversion. So this is the special property of plane mirror, that the image distance and the object distance will be equal, u equal to v, but the image will be laterally inverted. So that is a special feature, I'm just telling it. Now we'll be moving on with relation between velocity of image and object. You know that in a plane mirror, if we are moving the object the image also will move. So we are gonna look how velocity matters. Now there is a plane mirror here. Now I am keeping an object in front of it, O, and there is it is O in front of it with a relative velocity, and the mirror is also moving with a velocity Vm, and we have the object somewhere here at I, and it will be always moving towards the mirror, because what's happening here? Always if the object is moving to the front of the mirror, image should move in the opposite direction, right? Opposite direction. You know that if object is moving with V0 velocity, image should be moving the opposite direction with the same velocity. So this is the formula VOM, that is V, velocity of object with respect to mirror. If the mirror is moving, we cannot take with respect to the ground frame, because it will go wrong. So if the mirror is moving, we should take all the calculation with respect to mirror. If mirror is not moving, it will become just VOM will become VO minus VM. This is what V with respect to O means, right? Object with respect to mirror. If mirror is not moving, it will become 0. So it will just become the calculation. Look, I'm like stammering because I have to complete this, right? So that's what told here. This is not really in your syllabus, so we'll be moving fast. Nothing is told. The velocity of the object with respect to mirror will be minus velocity of image with respect to mirror. This is the equation. Please by heart this equation. Only you need this equation to solve the questions. Now I would like to ask you something. Look, now they are moving. These objects are moving parallel to the axis. If I am drawing an axis like this, they are moving parallel to the axis. If they are moving perpendicular to this axis drawn, with VO dash, then what will be the velocity of the image? This is parallel to the axis. Axis is drawn here. This is the axis, okay? They are moving parallel to the axis. If they are moving perpendicular to the axis, it's very simple that velocity of the object will be equal to velocity of the image, because if object is moving upward, image should also move upward. If object is moving downward, image should also move downward, right? You can try the same. You can take a ball, move in front of the mirror and look. You will understand it. Okay. Yes. Now, this is the basic concept of mirror. Now we'll be moving on with spherical mirrors. You know what are spherical mirrors? No need to explain. So there are two types of spherical mirrors. Sorry, what am I drawing? It's a lens I am drawing. So there are two types of spherical mirrors. One is convex one second, sorry. One is convex and one is concave. This is convex mirror, and this is concave mirror. Okay, now there's a basic assumption we are taking. That radius of curvature will be always 2 times the focal length. You just by heart it. Now there is what in NCERT the proper derivation is given, but no time to derive, so we'll just by heart it. Now comes the sign convention. What is sign convention? One second. For sign convention, we'll take a mirror, and if the incident ray is moving in this direction, then all the measurements taken in the direction of the incident ray, that is towards this side will be positive. So this side will be positive, and against this, that is above the left side of the mirror, will be negative. You should not learn like right side is positive, left side is negative. Just learn that in the direction of incident ray, this direction, it is always positive. Opposite direction of incident ray, it is negative. And from the pole will act as a zero reference, and from the pole to right, in this case to this side it's positive and to this side it is negative. And you know that above the principal axis it is positive, and below the principal axis it is negative. Okay, this is what you should learn in case of spherical mirror. Now we will be moving on with mirror formula. That is 1 by f equal to 1 by v plus 1 by u, which is plus 1 by u. It is 1 by v plus 1 by u. Very important. Okay. Now you know that the image can be magnified. Image can be erect, it can be enlarged, it can be diminished, it can be of same size depending upon the image formation. And the image formation for these two mirrors, for image formation, refer NCERT for mirror for image formation. Okay, it's given there. You can refer NCERT, but there is no time for me to explain the image formation, so we'll be moving on with magnification. There are 2 types of magnification. One is lateral magnification. When there is a mirror here, and I'm having my axis, and when the height of the object is taken, and we are having an image, somewhere we are having an image somewhere here. Height of image is this. So magnification is given by height of image by height of object. Okay, yes. But when we are deriving more, we get to know that this is u, object distance, and this is v, the image distance. When we are further calculating, we get that magnification equal to minus v by u. So just by heart it, no time to prove it, but just by heart. This and all should be by hearted. Now this magnifications, magnitude can be greater than 1, magnitude can be less than 1, or magnitude can be equal to 1. If the magnitude is greater than 1, that means enlarged image is formed. If it is less than 1, diminished or small image than the object is formed. If it is equal to 1, same size as the object is formed, same size image is formed. Now magnification can be positive and magnification can also be negative. Okay, if it is positive, we get it is erect, and if it is minus, we get negative, we get it is inverted, because erect means above the principal axis, so positive, and negative means below, that means inverted. Negative means inverted. That's the thing you should understand, because I'm so worried if I'll be able to complete in some time. So I think I'll make spherical mirrors one video, refraction one video, and spherical lenses one video, and optical instruments another video. I don't know. So I'll be making it like that. So this is about lateral magnification. Lateral magnification means height. Now there is another type of magnification known as longitudinal magnification. How can I take longitudinal magnification? Yes. Now if I'm having a mirror here, and it's silvered, okay, and I'm having an object. Instead of placing the object like this, I place the object like this. Okay. So the object length is LO. Now there is an image formed somewhere, and it's enlarged. You take it as enlarged. This Li length becomes Li. It is very thin object. Height is very less. Okay, height is very less. Only length is there. Then the magnification will be distance. This is V and this is U, object distance, and this is image distance V. It will be Li by LO, that is length of image by length of object, or minus V by U whole square. Very important formula, learn. Okay, this is the important formula, please learn. Now we have velocity of image. Velocity of image. You know that there is a mirror, and there is a object, and it is moving towards the mirror or moving somewhere. The direction means sign only changes. It is moving towards the mirror with a speed VO, and there is an image, and it is moving with the VI velocity. Okay, so to find the image speed, velocity of image, it is given by velocity of image by velocity of object equal to minus V by U whole square. Look, minus V by U whole square. So this is equal to longitudinal magnification. So very important formula by heart. Velocity of image by velocity of object equal to minus V. V means image distance at that specific time. Like if according to time, this position will be changed, but at a specific time, what is V or what is U is depending the image. Okay, depends on the velocity of image and velocity of object. Object distance is U, so minus V by U whole square. Okay. So by this, the concepts and the the formulas. So just learn the formulas that I put in a box. Learn the formulas that I put in a box. Okay, please learn the formulas that I put in a box. Very important. All the formulas I put in a box, please learn it. That is only needed for JEE mains examination. That's only important for JEE mains examination. And by modifying that formula, putting right, left and all, you can change and you will get the answer. But these formulas in the boxes are most important and very important for JEE mains. Without learning that, you will never qualify the examination. Okay, so learn the boxed formulas. I will be coming up with next video on refraction through prism and basics of refraction. So stay tuned for the same. Thank you.